All right, so this is continuing chapter 17 notes. The third big topic in chapter 17 is titrations. And what you could put in your notes is neutralization, because titration is really the lab procedure that we've done and we'll do in these two chapters. But really it's a neutralization reaction. So the neutralization reaction is acid plus base always gives you water and a salt. So again, with an acid, it's going to be the H part of the acid and the OH from the base that's going to essentially make the water. So for the net ionic equation for this, for a strong acid and a strong base, is going to be H plus OH minus makes water. Okay, that's the net ionic equation for a strong acid, strong base. So this only works for that, so you do need to know that, and I will talk about when you get to weak acids, they do not have the same net ionic equation, but it is one of those that you do need to know. So titrations is a way to figure out how much acid you have or how much base you have. Typically, you know one and not the other. So there are two ways to do a titration, okay? One way is to use what we call an indicator. And you might remember that from first year chemistry, where we did titration with an acid, where we used our favorite indicator, phenolphthalein. Or we could use a pH meter. And for one of the labs we do use a pH meter as well. So using the indicator, what makes that interesting or what makes that different is you will get a color change for a titration with an indicator, okay? So you always get a color change with that. So because you have a color change, we call it an end point. And that is physically when you stop the titration and you don't add any more to the sample, okay? So you stop the titration. If you have a pH meter, okay, you're going to have something called an equivalence point. And you do need to keep them separate in terms of what you're talking about. The equivalence point is where H plus is equal to OH minus, the concentration of those. So that's technically where you have neutrality, okay? So when you are doing a titration with a pH meter, you could create this curve, either one of the curves. One is just the flip of the other. This is called an S curve, and you could kind of tell why, because it is, it looks like an S, okay? So notice this is the volume of base, and this is your pH on the x-axis. So when you're looking at an S curve, okay, what you're looking at is a couple important things. So this is a titration with a strong acid and a strong base. So in the flask itself, okay, in the flask itself, you have an acid, and you put the pH meter into that flask, okay? So let's say, for instance, I am starting with a 0.05 molarity of my acid, of my HCl, and I'm starting with 50 mils in that flask. Well, if I'm adding NaOH, my starting pH is, of course, going to be close to 1 because hydrochloric acid is a strong acid depending upon the concentration. And then you will see as you add the NaOH that the pH will gradually start to go up and then go up and then level out. So if I know something called the equivalence point is always going to line up exactly at a pH of 7, okay? Because this is a strong versus a strong, and they will always have the same, it will always be H plus OH gives you water. So the pH is always going to be at 7 for the equivalence point for a strong versus a strong. So NaOH, in this example, if I made up some of this data, if I am looking at where the equivalence point is, I look down at where that intersects, and that intersects at about 25 milliliters. So NaOH is about 25 milliliters that I got to my equivalence point. So what has to be my concentration of my NaOH has to be about 0.1 because of the fact that I have twice the amount of acid in there that I had to add the base. And because HCl and NaOH are 1-to-1, that's going to be how it is. Now, if I did this titration using an indicator, okay, and our favorite indicator is, of course, phenolphthalein. Now, the interesting thing about phenolphthalein is it doesn't change the pH is greater than 8.2 when it turns pink. So that means if I go back to this S curve around 8 or just north of 8, this is where you get your color change. And you will see that that is going to be your end point if you had a phenolphthalein in there the same way as you would have a pH meter. And you sometimes see that on titrations. So look at the fact that the endpoint is higher on that S curve than the equivalence point. And we will talk about how we could remedy that situation a little bit later on. So take a look at this second curve. So this curve over here in the flask itself is the base, and you're adding acid to it along with your pH meter. Okay. So you are starting at a very high pH and then going to a low pH. Now recognize titration for a strong base with a strong acid, your equivalence point is still at 7, so that's no different here. It's just typically you see in the flask is acid and you add base to it. That's just because phenolphthalein changes color from clear to pink, so it's much easier for your eyeballs to see that. Rather than going the opposite way. So typically you have an acid in the flask, but you can also do it the other way. There's no rule against that. Okay. So what we're going to talk about is how with these titrations, how can we do some calculations with it? So that's going to be what the next video shows you.